All right, hey everyone. So the last time we talked about these kind of three random sampling mechanisms that we could use to take a sample to hopefully accurately reflect our population. And that's going to save us some time and money as opposed to doing a census and looking at every single unit in our population. And so we talked about stratified and cluster, and they could get a little bit confusing only because they both involve kind of dividing cases into groups. And so let's draw a little diagram to kind of hopefully illustrate the difference between the two, and then talk about some advantages and disadvantages of each. And so stratified, I'm just going to draw a small little diagram. And I'm just going to say that we maybe have 4 different groups that we're breaking up our population into. So remember with lakes, we did it with states, and there would be 50 of these little squares. But we don't want to draw 50 squares because we like stats, not drawing. And so let's say that each of these dots represents a different lake. So for stratified sampling, what we're going to do is maybe randomly select 2 lakes in each of these little squares, which kind of represent states. So maybe we're going to sample that one and that one, this one and this one and here, and then here and here. And so this is stratified. So each group is represented in some way. I'm going to leave a little bit of space to write an advantage in a sec. And over here, we're going to do a little diagram for cluster. So I'm going to draw it kind of similarly, but as you'll learn, I hate drawing because I'm terrible at it. So that kind of looks similar. It's supposed to be the same, but whatever. You probably did a better job than I did. So for cluster, what we're going to do is actually randomly select, maybe in this example, 1 or 2 groups. So maybe I randomly selected this group in the top left, and the other group that was selected was the group in the bottom left. Once we randomly select groups, we sample every single observation within that group. And so in cluster sampling, there are entire groups that actually don't get represented at all. So take a second to kind of think about an advantage of stratified sampling or an advantage of cluster sampling in terms of what gets represented, in terms of time, in terms of money, or whatever, wherever your mind goes. So I'll give you a second to kind of pause the video and think about that. Okay, so stratified, the advantage that I think of, so the advantage is that each state, or in general, each group gets represented. And they get represented equally because we're taking the same number from each group. You might also imagine that that can take, excuse me, that can take quite a bit of time. And so a disadvantage would be that if you're going to all 50 states, that's going to take kind of a lot of time and also a lot of money because you have to travel costs and all that kind of stuff. For cluster, the advantage is usually that that can save time and money, especially if you're sampling some geographic area like we are with states. So in this case, you only have to go to a couple states. That's going to save some time, it's going to save some money, and you're sampling everything within those states. The disadvantage, of course, is that these aren't represented in your sample at all. So there's whole regions in the US that could potentially just be not represented, which kind of sucks. And so that kind of leads us into this notion of what a representative sample actually is. And so a representative sample we're going to define as one that accurately reflects your population of interest. And so to be representative, that's usually like a good thing. We usually want our sample to be representative of the population that we sampled from. The thing that guarantees that your sample is going to be representative, or pretty much guarantees, is if you take a simple random sample. So simple random sample is always representative. I'm putting always in quotes because I usually don't like to say always or never because you could usually think of some weird setting where it's not true. But in this case, if you're randomly selecting cases, like in a simple random sample, that just by definition, you're going to get cases that accurately reflect your overall population that you're drawing those cases from. So simple random sample is the easiest way to get a sample that is representative. As we'll see though, it's often quite difficult to actually get a simple random sample. And so we'll see some examples of that in a bit.